Last week, we discussed the area of a sector of a circle. We began by reviewing that the formula for a full circle is area is equal to pi r squared. And then we quickly discussed a semicircle, which is half of a circle, which would obviously be area is equal to 1/2 of pi r squared. But we should also remember that a semicircle has a 180-degree central angle, and a 180 degrees divided by 360 simplified is 1/2, making it 1/2 pi r squared. Same thing with a quarter circle. A quarter of a circle would have a 90-degree central angle of the sector, and therefore 90 out of 360 is 1/4. So the formula would simply be the area is equal to 1/4 of pi r squared. But then, most importantly for us this year, we got to the any sector part. Well, the any sector part gave us two formulas, one which we discussed last week and one which we did not. The first one that we did discuss was that if you take the central angle of a sector, in this case n, whatever it might be, and put it over 360, you end up finding out what fraction of the whole circle you are looking for. And then we just multiply that by pi r squared. Well, this week we're also going to go on to talk about this alternative method, which doesn't use the central angle out of 360, but instead uses s, which is the length of the arc, over 2 pi r, which is the whole circumference. So the arc, the part of the arc over the whole arc, which is the circumference, can also tell you what fraction of the whole entire circle you're looking for. And then you can multiply that by the whole area, which is pi r squared. So let's take a look at that in a little bit more detail. Well, first, let's look at the one that we've already discussed in detail. And that is on the left side here, that the area is equal to n or theta, the central angle out of 360 times pi r squared. So let's just look at a quick example just to remind ourselves, well, what do we actually mean here? Well, let's just say that they tell us that the only thing that we really have given here is the fact that this central angle is 60 degrees. Well, therefore, we could say we have a slice of pizza here, a slice of a circle, a sector, which is 60 degrees out of the entire circle, if we went around the whole entire circle, which is 360. And if we put that in the calculator, math enter, enter, to simplify this fraction, we would get 1 out of 6, or 1/6. This slice is 1/6 of the whole entire circle, or the whole entire pizza. Therefore, we multiply 1/6 with the area of the whole entire circle, which is, in this case, pi r squared, the formula, whatever it might be. So that's what we've already done. That's the idea of that, using the central angle to figure out what fraction we are looking for out of the whole. Well, let's see how we can do that over here as well, using the arcs and the circumference. And I'm going to do a really, really simple version without pi, just to give you the idea of it before we look at an actual example. In this formula, you might want to remember that this little s here is really referring to the length of an arc, like say that arc right there, and that 2 pi r is really the formula for the circumference of a circle, and 2r is the same as diameter pi. But let's do one without pi, just to look at this more simply. Let's imagine that we had the card already written out for this particular circle on the right, and we knew that the whole entire circumference was just 8, right? 8 units, right? Pi has already been multiplied in, and it comes out to perfectly 8. And we also know that this arc over here, S, was equal to exactly 2. I'm really making a really, really simple problem to explain this formula. Well, then what we would be doing is we would know that the whole entire circumference is 8, and this part of it is 2. So we would put S, which is 2, over the whole circumference, 2 pi r, which is 8, and we'd simplify that to know that, oh, what we're really looking for is 1/4 of this entire circle, right? If I pull that out, you can see clearly that's 1/4 of the whole circle. And then we would use that fraction the same way we use the other one. We'd multiply that by pi r squared to get the area of that sector. So here on the left, we're using the central angle out of 360 in this formula. And in this formula, we're using a part of the arc over the whole circumference to find the fraction of the whole circle. All right, so let's look at an example of each, okay? So in this particular example number 1, it says find the area of a sector, a slice, with a central angle of 40 degrees and a radius of 12 centimeters. Express your answer to the nearest tenth. Well, let's remember that the formula for the area of a sector when I'm using the central angle is going to be my angle, I use theta here, out of 360 to get the fraction. And I'm going to multiply that by the area of the circle, which is pi r squared. Now out here on the side of my paper, there's really only 2 variables I need to use this formula, the angle and my radius. So sometimes I make a little table on my scrap paper. I say, well, do I have these things? I do. My theta is 40 degrees and my radius is 12. So I'm just going to substitute that into the area of my sector is equal to 40 degrees out of 360 times pi, and I'm going to substitute my radius, which is 12 squared. Now, I could put that all into my calculator, especially because they want me to round this off to the nearest tenth. So they want me to also put pi in the calculator. But I'm just going to simplify it so we really get an idea of what's happening here. 40 degrees out of 360, if I simplify that, is 1/9. So it's really 1/9 of the whole entire circle times the whole area, which is 12 squared, which is 144 pi. And if I were to give my answer in terms of pi, I would say, well, what's 1/9 of 144? And I happen to know that that's 16 pi. So that right there would be the answer in terms of pi, but they didn't ask for the in terms of pi in this case. They want the actual area expressed in the nearest tenth. They're always going to ask you to round off when you have a problem where there's pi involved. So I'm going to clear out my calculator and just put in 16 second power, which is my pi, and round that off to the nearest tenth, which is going to be 50.3. 50.3. And they actually gave me the units this time in centimeters. So I'm going to say square centimeters. And that is the approximate area of that sector. It's always approximate when you're rounding off. Now I'm going to use the new version, okay? So here's a problem where they're going to give me slightly different information. Find the area of a sector with an arc length of 30 centimeters and a radius of 10. Well, so in this case, I kind of have to remember the other version of the formula. The other version of the formula says, take the arc length, S, and put it over the whole circumference, which is 2 pi r, and then multiply that by pi r squared to get your sector, the area of the sector. Well, here, there's also 2 variables that I need. I need the arc length, which is my S, and I need my radius. Well, they're giving me both of those things. They told me that the length of the arc is 30, and they're telling me the radius is 10. So now I could go to this formula and plug all that in. Now, I'm just going to do something a little different here just to give you a demonstration as why I like to card so much. I know that this 2 pi r down here is actually the circumference. So whenever I'm given, say, the radius of a circle, and I'm pretty good at my card, I'm going to say, well, the radius is 10, the diameter, therefore, is going to be twice that, which is 20. My circumference in terms of pi is going to be 20 pi, and the area is going to be 10 squared pi, which is going to be 100 pi. So just by writing out my card, I have so many of these things already finished that I need to put into this problem. So the area of the sector is going to be equal to the sector arc length, which is 30, over 2 pi r, which is really just the circumference of the whole circle, which is 20 pi. And now I'm going to multiply this by pi, my radius, which is 10 squared. But I know that that right there, that pi r squared, is actually the area of the whole entire circle, which I already have in my card, which is why I like my card so much. I'm just going to put it in there already finished, which is 100 pi. And of course, I could put that in the calculator here, but I want to show you something nice that happens in this particular problem. Right here, I can say that 100 pi is the same as 100 pi over 1. And when you're multiplying, you could start simplifying stuff right off the bat. The pi's actually cancel each other out. Pi divided by pi is 1. 30 over 20 is the same as 3 over 2. And now I could say 3 times 100 divided by 2. I could do this all in my head. It's going to end up being 150 square centimeters. And there you have it. I used the arc length over the circumference to figure out what fraction, which was 3/2 of the circle. All right. So here is another quick example, a little bit more technical. Let's see if we could handle this one. Find the area of a sector shown at the right. The radius of the circle is 5 units, and the length of the minor arc from A to B is 3.9 units. Express the answer to the nearest tenth. Okay, so here we're going to use the formula which states the area of the sector is going to be the length of the arc over the whole circumference, which is 2 pi r. And I'm going to multiply that times the area of the circle, which is pi r squared. Well, again, I'm going to work down here. I need my arc length and the radius. That's it. Well, the arc length is 3.93, and the radius is 5. Now, sure, you could just substitute that all in, and that is absolutely fine in this particular problem. You can say 3.93 over 2 pi times your radius. If you wanted to do it like this, you could. Pi radius squared. However, I kind of like to use my card. I just want to show you why I do that, because I see that I have a radius of 5. I see if I have a radius of 5, that means I have a diameter of 10. I have a circumference of 10 pi, and I have an area of 25 pi. So then I see this more. I kind of jump right to this part where I say, well, it's 3.93 over the whole circumference. Well, 2 times 5 is 10, 10 pi. See, I already had that over there. 10 pi times 5 squared pi, which is 25 pi. Now, again, it's true that the pi's cancel out. And then in your calculator, you could just multiply 3.93. I'm going to go across times 25. And then I divide that by 10 on the bottom. And I get 9.8 as to the nearest tenth, which is right there as your answer. 9.825, but to the nearest tenth. Okay, and I'm going to skip over this problem now because we've done a whole bunch of these, and I'm just going to jump to this last part that I want to go over. Um, in last class, we did part one and part two. So here's the last thing that I would like you to be able to do when we're working with sectors. And that's kind of reverse engineer one. These are problems where we're looking for the radius of the circle given the area of the sector. So we're actually going completely in reverse. So let's take a look at this first question and see if we could just figure it out if we stick to the formula and what's given to us. Find the radius of a circle in which a sector whose central angle is 40 degrees and has an area of 16 pi. Now, that 16 pi is not the area of the circle. If you read that carefully, find the radius of a circle in which a sector whose central angle is 40 degrees has an area of 16 pi. So if we were to look at the formula as the area of a sector is equal, and this is giving me, I'm going to use the central angle one, it's the angle out of 360 times pi r squared. So in this particular problem, what's given to me is the actual area of the sector and the angle. They're telling me that the area of the sector in terms of pi is 16 pi, and that the angle is 40 degrees. It's the radius that I'm looking for. So I'm going to substitute the area of the sector here at the beginning. Say, well, 16 pi is equal to 40 out of 360. That's 4 times pi r squared. Well, if I simplify 40 over 360, that's 1/9 times pi r squared. Now, I told you last class a good tool to use when you're solving these complicated equations is that if you have a constant on both sides of an equation and it's just a product, as this is, we can actually cancel out the pi's, pi on one side and pi on the other side. And then I'm going to rewrite this here on the other side. I'm going to go over here. Is 16 is now equal to 1/9 r squared. Well, there's a couple ways we can get rid of this 1/9 to get the r alone. One way is to multiply it by its reciprocal. So I'm going to multiply this side by 9 and this side by 9. And then we end up with 144 is equal to, those cancel out, your r squared. And then square root both sides, and we get the radius is equal to 12. And that is how that works. Now I'm going to show you one more problem here, but I'm going to try to illustrate it for you as well. This we'll call it, and then that'll be the last problem we do. So let's take a look at this problem right here. Take it to a new page. Okay. So what I'd like to demonstrate what's actually happening here. Basically, they're saying find the radius of a circle in which a sector whose central angle is 72 degrees has an area of 5 pi. So what they're actually giving us here, as is in the previous problem, is imagine it's a circle. They're telling us in this circle there exists a slice, and that this slice has a central angle of 72 degrees, and the area of the slice is 5 pi, right? All of the space right here is 5 pi, not the whole circle. Therefore, what would be the radius? So that's really what they're asking us for, right? To reverse engineer this whole thing. Well, the area of a sector is equal to whatever that angle is out of 360 times pi r squared. That means 5 pi is equal to 72 out of 360 times pi r squared. Well, 5 pi is equal to 72 actually goes into 365 times, so it's 1/5 of pi r squared. We could eliminate the pi's because they're on both sides, and we get 5 is equal to 1/5 of a radius squared. Well, how do we get rid of that 1/5? We multiply by the reciprocal on both sides, multiply by 5 on both sides. You're going to get 25. 1/5 and the 5 cancel out is equal to your radius squared. Square root, the radius is equal to 5. Now, if you happen to know that 72 degrees goes into 365 times here, if I did it the other way, say 360 divided by 72, you would know that this pizza was cut into 1, 2, 3, 4, 5 slices, and that each one was 5 pi area. Well, 5 times 5 pi would have been 25 pi is equal to the area of the circle. Well, you know that this is equal, if you card up now, you would know that the radius is take off the pi and the square root. So you can also figure out some of these problems in your head if you understand what is happening. Well, there you have it. I hope you found this video useful. If you did, subscribe to Mr. Frank's YouTube channel. Have a great day, everyone.